Hello, welcome back. To consolidate what we have learned about Matplotlib, we will now do a couple of exercises to practice, okay? On the first one, we will plot multiple functions with a legend, and the second one, we will create subplots for trigonometric functions. Let's start with the first one. We will use Matplotlib and NumPy, which is what we have been using. We will square the x and elevate to 3 the second on the same graph. We will first create 100 even spaced x values ranging from -5 to 5 using linspace. Then we will square and then elevate to 3 on the same graph, labeling the curve and then adding a legend according to these labels and display the final plot. So let's start this Matplotlib, pyplot splt, import numpy. If you watch the videos, even if you are a newbie, you already know that we have to import the libraries. And then let's use this function which we have been using a lot to generate new data. The second will be to add to square the first one to generate what we want. Now we ask to label. Let's label this. Let's keep it like this. Okay. Well, we will wait to treat the second one. Then we wanted, so we already did second step and third step. We now want to add a legend to this. A legend, okay. And we wanted to show the plot, and that's it. There you have it. That's what we wanted. Okay, really nice. And we have the sign, the elevated to 2, elevated to 3, and now elevated to 3, elevated to 2, from -5 to 5, and with the legends right here labeling these curves. So, second exercise, let's go here, start here at the bottom. What we want is to display sin of x, cosine and tangent as 3 separate subplots stacked vertically, which mean 1, 1, 2, 3. First we create a figure, then we use subplot to arrange 3 rows, 1 column, only 1 column, 3 rows, 1, 2, 3. For the first subplot, we plot sin of x and give it a title. For the second subplot, we plot cosine. For the third, the tangent. Then we have to arrange the spaces so titles, labels, and axes don't overlap. We already know an easy way to do this, okay, from the previous videos. And we display the final figure with all 3 subplots. So let's get this over with. Let's get this started. We already have the libraries that we need, NumPy and pyplot there, so we can just start. First, start a figure. Fix size. We can keep it this. I'll increase here a little bit. So the first subplot, using subplots, we refer to subplot 3 rows, exactly. This is the scene, it's not this. we plot the x, we use numpy, we can leave it like this, right? Plt sub plt, we give the title. Now we should be sine. We can do the same for the cosine. We could copy paste, but let's continue to subplot 3, 1, and this will be the second one there. Plt. That's alright, it's auto-completing very well. So yes, now we want this one. For this we want the tangent. So and we have we need a title. Yes. So we have created a figure, then the 3 subplots, 3 rows, 1 column, first subplot, second subplot, third subplot, sine, cosine, tangent, and we have the names. Now to make sure the titles, labels, and axes don't overlap, and also that we will not arrange each and every one of these plots, we will just use this tight layout. I end up using this a lot on the plots because they stay very arranged automatically, even if sometimes it decreases a little bit the size of the letters. We can arrange them if we need. Okay, this is what we wanted. 1 subplot, 2 subplots, 3 subplots with a tight layout. If we didn't have the tight layout, they would overlap somewhat the titles. Yes. Okay, so this is what it does. We don't need to arrange, it doesn't overlap. So that's it. Let's just see the code that we have. This will be the answer to this exercise right here. Okay. First the figure, first subplot, second subplot, third subplot, tight layout, and then we show, and we have the 3 plots. There you go. Thank you very much again, and let's see on the next topic. Thank you. You can also like and subscribe, and let's go.